Well, let's get started with some integration problems. Everybody take out your notebooks and copy down these problems. Substitute teacher, please pause the video for a few moments and let the students work on these. Guys, when you're integrating these warm-up problems here, let's go with no calculator. No calculator. If you need to talk to a buddy to refresh your memory on a trick, go ahead. But give it your best shot. And substitute teacher, please pause the video and give the students about 5 minutes to work on these, and then we'll go over the answers together. Okay? So please pause the video before I count down because the answers will display in 5, 4, 3, 2, 1. Okay, you can see for problem number 1, we just had to do a little algebra trick to rewrite the integrand, and we were able to integrate to get 3x squared plus the natural log of the absolute value of x plus a constant. For problem number 2, we had to do some u substitution, and we were able to get 1/3 times the quantity x squared plus 4 to the 3/2 power plus a constant. But in problem number 3, we run into a dead end. There's no algebra trick that we can use to make this integratable. U substitution doesn't work. So we need a new technique. Either that or this problem is just not integratable. So just make a little note here. We need a new technique. And that's what we're going to talk about today. This technique is called integration by parts. IBP for short. And that's it. With the integration by parts technique, we're able to integrate problems like problem number 3. Now, one sign that we could run into trouble, the u substitution will sometimes work, but sometimes not, is when you have a power function, like x to a power, and then a transcendental function, like an exponential or logarithmic function, or arc-trig function. So take out your notebooks. Well, you should have your notebooks out already, of course, and let's get started. Okay, you can see we have a formula here where we're going to break down our integrand into 2 parts, a u and a dv, and we'll use a formula. The integral of u dv is equal to u times v minus the integral of v du. Now this might sound kind of crazy and seems arbitrary, but we're going to show you later on after this first example, we're going to show you where this formula came from. So right now all we need to do is try to work through this problem. So if I remember right, number 3 was the integral of x times e to the x dx. Okay, like some other techniques, the more experience we get, the better we'll get at selecting what to sign as u and what to sign as dv. So just for starters, we're going to let u equal x, and we're going to let e to the x equal dv. Now, there's a little chart we like to use to keep our thoughts straight. And copy this down in your paper. We're going to make 4 little squares here, 4 little quadrants. And on one side, we're going to put u. And then, of course, we're going to have to find a du. The derivative of x with respect to x is just 1 dx. Let's write our thoughts. Then over on the other side, let's put our dv, put the d's on the bottom here. dv equals e to the x. And if you integrate with respect to x, we'll get that v equals e to the x. And we're not going to worry about the constant for right here, right now. Okay, so now it looks like we have the pieces of a puzzle together. Well, almost together. We're going to say that the integral of x times e to the x dx is going to equal, now remember, we let u equal x, and we let dv equal e to the x. So let's see how we can put this together. U times v, that's going to be x times e to the x, minus the integral of v du. So let's see here, the integral of v, which is e to the x du. du is 1 times dx. Okay, now the goal is right here to have a simpler looking integral. If this is something we can integrate, then we're in business. If this is something that we can't integrate, well, then maybe we should start over, try assigning a different value to u and a different value to dv. I just started on dv. So anyways, we can work this out now. We're going to get x times e to the x minus the integral of e to the x is e to the x. And of course, we're going to wrap this up with our plus a constant. The integral of x e to the x dx is equal to this expression. Now we have a few minutes left before we have to stop the video and go to part 2. So let's show you where this crazy integration by parts formula came from. Let's start with something like this. Let's say you've got a product of two functions, u times v. Let them each be a function in, if you want to find the derivative of u times v, remember the product rule. That'll be the first function times the derivative of the second, it'll be dv dx, plus the second function times the derivative of the first. Okay, now that's for starters. So if you think of it, if we came along and integrated each term with respect to x, let's see what would happen. The integral of the derivative of the product u and v is going to be u times v. And this is going to equal, let's see, the integral of u, the dx's cancel, u dv, plus the integral, let's see here, the dx's cancel, of v du. And if we want to isolate this integral right here, we need to subtract the integral of v du from both sides. So we're going to get u times v minus the integral of v du equals the integral of u times dv. So that's where the integration by parts formula comes from. You know, it's not just something magic that mathematicians pull out of the air. Well, guys, now it's time to just do a bunch of practice and try to get the hang of integration by parts. Let's see if we can get one problem in here during this 10-minute video. Okay, let's integrate x squared times natural log of x dx. Let's just look at a couple things here. Number one, you can try to use substitution. The toughest thing about integration by parts is recognizing when you need to use this technique. And the best way to determine when you need to use this technique is when nothing else works. So use substitution is not going to help here. I'll just tell you that. Let's get started with our by parts technique. So let's let u equal x squared, and let's let dv equal the natural log of x dx. You can tell we're going to run into some trouble right away. At least I can tell. And we go to make our little chart. We got u is x squared, so du is going to be 2x dx. We got dv equals the natural log of x dx. So we go to integrate. We don't know how to integrate the natural log of x. There is a way to do it. There's a formula in your book, but we don't know it. So we're going to have to try to reassign the u and the dv. And we're running out of time. So what we're going to do is we're going to stop this video and continue this problem in the next video. So when this video stops, please play part 2 of our lesson. Thanks for watching the video.